Well, good afternoon, everybody. First of all, just like to thank the conference organisers for inviting me to present this afternoon. As you can see, I'm presenting on fire safety in mass wood buildings, something which has come up a few times this morning already, and it's something which is very close to my heart and something which I enjoy working with. At the moment, mass wood buildings is certainly something we're starting to see become a reality here in the US, and that's something which is, brilliant. It's fantastic that we're starting to see a movement towards more mass wood buildings. But there are some problems that we're still yet to solve. There's still some issues that we still need to work through, and so what this presentation is about is just to talk about some of those issues that I see that we still need to address and will need to address for a number of years from a fire safety point of view, and basically look at some of those solutions and what we can do about those. Two key things I want to talk about is this issue of perception of risk. And fire safety in mass wood buildings is particularly, in some ways, hamstrung by the fact that we have this perception of risk issue. And it's something which comes up again and again. I'd also like to just touch on the issues of exposed wood and how we deal with exposed wood from a fire safety point of view. And through this presentation, one of the other issues I think which is important that's come up already today is the issue of education. And that's education of not just practitioners, architects and engineers, but also authorities as well, building officials and fire department personnel as well, who are also involved in the construction process. And AWC, WoodWorks and a lot of other organisations do some amazing training, but I think we still need to work on the whole education process. One thing that's, I think, been a significant step change over the last 12 months is the USDA tall wood building competition. That has meant that mass wood buildings has suddenly had a significant amount of press coverage. Architectural magazines, Wall Street Journal, Washington Post, there's numerous articles and a lot now archived away on the internet. When you search for the USDA tall wood building competition, there's an enormous amount of documentation on that, and it's raised the profile of mass wood buildings here in the US. That has had a significant impact in the construction industry starting to understand what CLT is, starting to understand what glulam is and how to use that, starting to look at other products like NLT, and trying to work out how those can be put into normal light frame buildings. And that's something which I think is a significant step where there's more of a conversation now around 3- and 4-story mass wood buildings, where previously they were all light frame. Now they're starting to be looked at as code compliant mass wood buildings using products like CLT. And the American Wood Council has done a lot of work in getting CLT into the 2015 IBC, which is now slowly being adopted around the US. And now CLT is becoming, a compliant material which can be used. So that's a really important and positive aspect. And we need to see a lot more low-rise CLT buildings and mass wood buildings, because we can't get to the larger buildings until everybody's more familiar with the smaller buildings. And that's important from a fire safety point of view. With fire safety in mass wood buildings, there's this enormous perception of risk. And that creates a lot of problems. When we want to develop buildings and potentially then work through those, get them approved and get them constructed. Basically, perception of risk is all about these 3 items: the likelihood, the consequences, the understanding and the familiarity. Typically what we see is a real aspect of, in some ways, amount of fear around fire safety when it comes to mass wood buildings, because there's, in some ways, this perception that somehow a building constructed of wood is more likely to have a fire than one that isn't. Now, the reality is, all buildings are created in some ways quite equal. They all have typically the same fire protection systems. An office building, whether it's constructed of steel or concrete or wood, is still going to have the same operations in it. The likelihood of fire is pretty much exactly the same in most buildings. The reality is that often those issues of likelihood are more related to the consequences, and that the perception of risk is related back to what are those consequences if a fire does occur. There's a real issue and a perception that if there is a fire in a wooden building, you're going to have worse consequences than there would be in a steel building. And the reality is that's probably not the case. And that's one of the issues, which is this whole issue of perception. And part of that is the understanding. What we're seeing is there's not enough understanding of mass wood. I want to talk a little bit more about where those issues lie, but really the issue is, what is a mass wood building and what does it look like? How does it go together? How do those connections work? How does it constructed with services risers, utilities going into a building? And all of those aspects from a fire safety point of view come together because it's this lack of familiarity with mass wood which starts to put barriers in the way of it actually being constructed. And it's all related back to fire safety. So there's going to be an acceptance problem for mass wood buildings for a number of years to come. And I think, the continuing education will continue to occur and we'll start to lift the game and raise the profile of mass wood buildings. And there's a lot of engineers and architects and authorities and constructors who will start to learn a lot more about mass wood buildings and start to understand that there is a fire safety risk, but that fire safety risk can be managed. In the same way there's a fire safety risk in all buildings. So there is going to be a slow acceptance and we need to work with that and we need to be able to try and work out how to improve that and try and make sure that mass wood buildings and in some ways all wood buildings aren't basically held down by this perception of risk. So some of the issues we see and some of the confusing aspects that we regularly see, and some of you probably would have seen these as well, is that there's a confusion between mass wood building and a light frame building, probably from a fire safety point of view. There's a misunderstanding of how a mass wood building actually goes together, and there's a perception that it looks and goes together very much like a light frame building, which is completely incorrect. There's a real issue that construction fires that occur and get a lot of press coverage are very much like actual fires in a real building once it's actually finished. The reality is they're completely different. A construction fire is very much related to an unprotected building and a half-finished building. That is not at all what's going to happen to a building which is actually finished. And the reality is a lot of those fires are actually based around arson. Mass wood potentially has a lot of concealed spaces, and it's completely the opposite. Mass wood buildings have very few concealed spaces. There's a real issue related to concealed spaces and fire spread, and it's a real issue. Mass wood buildings, CLT buildings, glulam buildings don't have those similar issues, and so that misconception can certainly go away pretty quickly. CLT has become synonymous with delamination. Most people don't even know what delamination is, but it's a sort of magic keyword that goes together. CLT, fire, delamination. I regularly ask people when they raise that, what does it mean? And generally they can't really tell me. But I still have to explain the process of what delamination actually is and work through that with them. But it's an interesting aspect of trying to explain that and how quickly CLT, fire, and delamination have suddenly come together. One of the things I really want to talk about, though, and just give you a few examples on, is this issue of a lack of substantiation. And this relates back to the amount of substantial fire data we've got on wood products and supplies. And this has been an issue we've had for a number of years. It's not a CLT problem, it's not a glulam problem, it's not an NLT problem, it's a engineered wood problem. And the fact is that we need to get over this issue of an insufficient substantiation, insufficient data, because the lack of that basically implies that there's a higher risk associated with wood buildings. So when a building goes through an approval, we've got all these people who need to be happy with the building and happy with the way that it's working. There's an architect who has to sign off that he's happy with all the materials going in, that everything's in the right place, the fire ratings are in the right location, the fire doors are in the right location. There's an engineer who has to sign off that everything is going to be constructed the way it will be and has to go through a design process and sign off on that. There's a building official who has to be happy with the way that the building has been designed, and the fire department has to be involved as well, typically on most buildings, to sign off and agree with the fire protection. And most mass wood buildings are going to have an independent inspector. That's the reality. For many years to come, they will have an independent inspector as part of that construction process who needs to be happy as well. All of these people rely on suppliers. And this is the part that's missing at the moment. All of these approval steps need information from suppliers, and we rely on that. It's the same in the steel industry, the concrete industry, wood is exactly the same. We need that information to be able to make sure that we're signing off and actually make sure that we're approving things as best as we can. And at the moment, we're lacking in that information. There's a real lack of sufficient data from the suppliers. And it's good to see there's enough suppliers, hopefully here and downstairs, and I've been talking to a lot of them about this issue, and many of them are aware of it because I regularly talk to them about it. So I want to talk about a couple of missed opportunities, and this is basically to explain the issues that I see. Pretty obvious question, what's less than one? Well, 0 is less than 1, obviously. And what this relates to is the fact that we had a project, there was a project that was being planned. It was a very large, low-rise building, steel frame, was going to have CLT floors. And a lot of the CLT floors were going to be exposed from the underside. Relatively straightforward. The approval authority in question basically said to me, happy to look at that, seems pretty reasonable. One of the things we need to see is we want to make sure that the CLT that's going to be used has been tested here in the US. And I said, we don't actually have that at the moment. And he said, so you're telling me that you want to put CLT into a building and you're expecting me to approve that, and there's been no fire test of an exposed CLT product actually here in the US. And I said, that's exactly right, there are no tests. And he said, basically, I don't think I can approve that. And I think that was probably a reasonable outcome, given the fact that there was no CLT, and there still isn't to this date, a CLT product which has been tested, exposed here in the US to an ASTM E119 fire, which is the standard fire that the IBC calls up. And that's disappointing, and it's frustrating. And that project has got concrete floors now, or will have concrete floors. So it's a significant missed opportunity because of this issue of not enough data, not enough testing substantiation to back up the product. Just another example, 10 does not equal 60. Basically, we went through a process with a building. It was a medium-rise building. It was an office building. It was going to have a steel frame, a concrete core. They were going to have CLT walls and CLT floors, parts of the building. A number of those are going to be exposed. The building official in question basically said, this all looks pretty reasonable. The fire department were starting to look at it, and they were starting to be on board as well. And they said, we've looked through all the fire test information you've sent us. There's stuff from Europe and there's stuff from Canada. Basically, they said, we've looked at all the Canadian tests, and the amount of testing that's got exposed CLT, walls or floors, the number of tests is about 10 tests. And what they did was they then said, we called one of the major gypsum suppliers and asked them how many fire tests they'd carried out on wall and floor systems. And they said they'd probably carried out about 60 fire tests, probably more. And that's just one of the gypsum suppliers. And there are multiple gypsum suppliers. And so what they said to me, which was a pretty reasonable outcome, was that they didn't want to approve that building because as far as they could see, there was no test carried out in the US with exposed CLT. And the number of tests that were actually carried out was only about 10. And as far as they were concerned, that probably was not enough to be able to sign off on that building, given the fact that the gypsum suppliers, who are basically providing an equivalent product as a fire-rated wall or a fire-rated floor, as it would have been, have carried out numerous tests here in the US, and basically a lot of them are UL listed as well. And that was a reasonable argument. I couldn't argue against that. I think that's pretty reasonable. It's a disappointing outcome, and it's a real missed opportunity, because again, that building pretty much is not going to go ahead now, because the developer would like to put CLT into that, would like to put wood into it. So those are the issues that I see as being a real problem for us. And it's this. And the other issue that came up was that the same authority gave me a call a little bit after that and basically said to me, is there a problem with the fact that CLT and mass wood products, they don't want to actually burn them in furnaces? Is it a problem with the fact that they don't want to test them? And I said, look, I'm sure that's not the issue. And he said, well, the fact that there's not this testing going on, does that mean that they're actually scared of what the outcome will be? And I said, definitely not. It's definitely not that. And he said, well, that's what it appears to me. It appears to me like they're actually scared to do these tests because they don't want to see what the outcome is going to be. And it clicked to me that that was a real problem. We probably lost that building official. To him, the lack of testing and the lack of data is basically, to him, is basically showing that there's a real perception of risk with those products. It's disappointing, but that's basically where we're at. And so from my point of view, for us to have more mass wood buildings, for us to have more wood buildings generally, we need greater substantiation. The gypsum guys come into meetings and they have huge folders of fire test data and a whole lot of information. I go into meetings with a small amount of information, and the reality is that I get the pushback simply because we don't have that substantiation and because we don't have that data from the suppliers. So certainly we need to improve that risk perception by the suppliers, and a whole lot of people starting to get more on board with the actual substantiation. So this is one of the key things, I think, is that we need to basically be able to understand where that risk perception is and how we can improve on that. And basically a lot of that is related to actually having data that is usable for the architect, the engineer, the building official, the fire department, and the independent inspector to all use to be able to have sufficient sign-off. Okay, a little bit about exposed wood. We all want to have exposed wood in our buildings. Looks great, it's fantastic. The issue is it's a fire safety problem. That's the reality. It would be great to have more wood in buildings and have it exposed. At the moment, there's a certain limited amount of testing which has gone on, mainly looking at CLT as an exposed wood element as part of a building. The issue we face is that the walls and the floors, if they are part of that structure, you've got a combustible element which is load-bearing and is combusting if the fire happens to grow and develop. So that's something we need to get our heads around, is the fact you've got a load-bearing structure which is continuing to burn and continuing to carry the load it needs to carry. For that to occur, we've got to have a number of things that have gone wrong. Typically, we've got to have the sprinklers not work, which is highly unlikely, and we've got to get to a situation where the fire department potentially can't control that fire, which again is highly unlikely. So it's a very low likelihood situation. But we have to design for that, and we're asked to design for that. So exposed wood is something which the industry is wanting. There's a number of researchers who are wanting to carry out more testing, and there is certainly more testing going on in a number of facilities. The company I work for, we see this as being a major issue that needs a lot more input and a lot more work. We're funding some testing at one of the major universities. We've got a CLT supplier on board. In the next 3 months, we're going to be doing a whole lot of compartment tests, which we're basically mostly funding because we want to find out the outcome. And we think basically most of the research organisations are probably going to be moving too slow to be able to get this information out to us, which is realistic. You know, people are doing masters and PhD projects. They need to be taking their time on this. But it's an important aspect. It really is. And the real key aspect here is how the exposed wood changes the fire dynamics, how it changes the fire curve and the way that the fire actually reacts. And the main issue is not the growth part of it, but basically how long the fire burns and how long it takes to decay. And that's the real mystery part. That's the part we're trying to work on and trying to solve, but the issue is that the more wood you expose, the longer the fire takes and the longer time it takes to decay. And you've got to make sure that that load-bearing structure can continue to resist the fire for longer than potentially you thought it may be because you've got this exposed wood. So it's a real issue. But part of that also, the issue with that is the fact that a lot of approval authorities and a lot of engineers working in similar industries and working in the industry of mass wood are asking some pretty hard questions of structural wood. We're asking questions about how it performs very long term into long detailed fires, and we're wanting to understand what that performance is. The steel industry and the concrete industry really aren't facing some of these same questions. And it's interesting that to overcome these issues, we're really only going to get there by doing a lot more detailed research, and that takes time. So I expect we will still see, and we will be able to design a certain amount of exposed wooden buildings, but we're never probably going to get to the point where what the architects want, which is a lot of exposed wood, for potentially another 5 or 10 years, once we get a lot more research carried out. A couple of slides just to finish off on connections, which is something I really enjoy. We can't all be Shigeru and design connections which look as beautiful as this, but there are certain buildings where connections are really a real problem in a lot of buildings. The real issue is when we've tested glulam connections in particular, and glulam to glulam connections are one of the more important ones because if you're designing a CLT building or an NLT building, you're probably going to have glulam in there as part of the structure. And those connections need to be able to withstand a fire for 1 hour or 2 hours. There's been research going on since the 1990s, and this is a nice photo that I took back when I was doing research of us doing oven tests on connections. And the reality is the work that's been going on still continues today on connections because we haven't solved the problem. And it's a real mystery in some ways as to why we haven't, but we're getting a lot closer to it. There's an increased charring rate at connections, and that is something which is something we need to account for, and it's partly to do with how much steel is exposed, but even when the steel plates inside a connection are actually concealed, we still get an increased charring rate, which is really interesting, and the physicists involved in this actually really enjoy the physics involved. It's actually not an engineering problem, it's a physics problem. The wood strength and stiffness starts to decrease at around 60 degrees centigrade, 140 degrees Fahrenheit, which is a low temperature. It doesn't take much to be able to get the wood up to that temperature before the strength and the stiffness starts to drop in the connection. And the other issue is that we've got wood when it's burning, which is decreasing in volume as the fire continues to burn, but also it's decreasing in volume and decreasing in strength because it's warming up. So we've really got a problem in chasing our tail of trying to provide the strength when we're reducing in the volume that we need to resist the applied loads, but also the strength is reducing. So there's a lot of complexities involved in the connections, and there's still a lot more work to be done. And unfortunately, there's probably not enough research going on in this area. Again, it's a similar sort of issue. We need more research and more work in the simple aspect of connections. So it's interesting to basically look at what some of the other industries are doing with connections, particularly the steel industry. And for some reason, the steel industry doesn't actually fire test their beam and column connections. And there's been some, I'm trying to dig out why, but a lot of it's partly to do with some good lobbying by the steel industry, and partly also driven by the fact that there's a general acceptance that steel connections perform relatively well in actual fires that have occurred. It's interesting that wood doesn't have that same relaxation or approach, and that's because it's held in some ways to a slightly higher standard than a lot of the steel construction. And again, that's an issue of perception of risk. So just in summary, I think when it comes to fire safety, we've come a long way. There's a lot more investment into research and testing going on, which is brilliant. There's certainly a lot more needed. There are still a lot of challenges from a fire safety point of view for mass wood buildings. We're working with a number of researchers and a number of organisations to be able to try and get some of this data and some of this information we need. But it is still going to be a problem for a lot of the mass wood buildings going forward. And this perception of risk issue needs education, it needs understanding, it needs familiarity. And we need to continue to work on that, because it's not everybody in this room, you know, that basically are the issue. It's everybody outside the room who doesn't really understand what a mass wood building is, or thinks that it still has concealed spaces, or, you know, thinks that basically delamination is some problem related to wood somehow. So those are the things we need to continue to work on. But as we do, we will start to solve more of those problems related to fire safety, and hopefully we will get a lot more mass wood buildings. Thank you very much.